Okay, good day, grade 10s. Yeah, this is our first video for our lessons. Yeah, if you look in front of you, you have your ATP. This is your ATP for term 1. So if you can see, for term 1, you only have 3 topics to do. You have the waves, sound and light. Then topic number 2, the green one that I highlighted, green, is electrostatics. Then the last topic is electric circuits. So these are the topics that you are supposed to do for term 1. The first topic, which is the waves, they are divided into 4. You have transverse waves, pulse, longitudinal waves, sound waves, electromagnetic radiation. So we did part of this last time we met. Then we did also electrostatics, but we haven't done electric circuits. So what I'm going to do in this video, I'm going to explain the basics of electric circuits, and then we are going to do a question in electric circuits. Maybe I'll do 2 or 3 exam questions, then I'll go to electrostatics, I'll do 2 or 3 exam questions, then I go to E-waves, I do 2 or 3 exam questions. Okay, yeah, in front of you, you have a electric circuit example. This is a basic, simple example for electric circuits. So I'm going to use this example to explain to you the basics of the electric circuit. So this in front of you is the combination of the E series and E parallel. So I'm going to read you explain to you the diagram of the electric circuit, and then we will go through the questions, and then we do calculations. This is taken from grade 9 electric circuit question. So when you look on your left, you have a battery. This is a battery with a 60 volts. A battery with a 60 volts. Okay, so what we know is that your current will come from the positive side of your battery. This is the positive side. This is the negative side. The longer side is the positive side. The shorter side is the negative side. So your current will come this way. The current from the battery will come from this side. So we call that the conventional current. So current will come this way from the battery, and then current will pass through R1. And then when current comes to this point, there are 2 resistors in parallel here. So the current will split. Another part will go to the left. Another part of the current will go to the right. So I'm going to call the current that went to the left, because it's going to the resistor that is called I2. So this R2 will receive current I2. And then on the right you have R3. So I'll call this current going to the right I3. And then it will come to this point, and then it will go straight to R4. Then the current will go that way. So I call this one I4. This one we call it I1, because going through R1. So let's revise again. We said the total current, the current that comes from the battery, we call it I total, is the total current. So it's going through. So R1, if you can see, is going to receive the whole current that came from the battery. But when the current goes to this junction, it splits now. So R2 is going to receive a certain amount of current, and R3 is going to receive a certain amount of current. Then when that current joins at this junction, it's going to go all of it through R4. So R4 and R1, they are receiving the total amount of current that came from the battery. When it comes to voltage now, look at here, this is a voltage. Okay, let me just give you a simple revision here. A simple revision. From grade 9, we said that series series resistors, we know that current is the same. But for parallel resistors, we used to say, in parallel resistors, we used to say current divides. Or separates. As you can see that the resistor R1 is in series with the battery, it's receiving the whole current, and the resistor R4 is in series with the battery, it's receiving the whole current. So the current through R1 and R4 is the same, is the current that came from the battery. But these two resistors R2 and R3, they are in parallel. So resistors that are in parallel, the current will divide, so it will receive a split of the total current. And then let's look at the voltage now. The battery produces 60 volts. Resistor 1 will receive a certain amount of the voltage, and resistor 4 will receive a certain amount of the voltage, and then these two resistors in parallel, they will receive the same voltage. You will see when you do the calculations. So we say for series resistors, voltage divides. So the voltage will be divided for the series resistors, you will see. But for parallel resistors, we say voltage will be the same. Voltage is the same. So just keep these two in mind. Keep these 2 points in mind. I'm going to erase the 2 now. Then later on we will see the reality of these 2 statements. So let me erase this first one. So I just want to create space for our calculations, because we're going to go through calculations now. So let me delete this one, and then delete also the second one. So we delete these 2 statements so that we go to our questions. Okay, yeah, before we go to questions, just check the formulas. Let's check the formulas. There are 5 formulas that you must know in order for you to be able to answer any question in this topic. So the first formula is the formula that we know called the Ohm's law. So we used to do that triangle in grade 9, and then we put the V on the top, we put the I on the left, we put the R on the right. As you can see, V is a numerator, I is a denominator, and R is a denominator. So if you are required to calculate voltage, which is V, we say V is equals to I multiplied by R. In other words, the voltage is equals to current multiplied by resistance, and the units for voltage is in V. Again, if they want you to calculate the I, which is the current, we say I is equals to V over R. As you can see here that I is equals to V over R. So V is a numerator, R is a denominator, and the current is in amps. If they want you to calculate the resistance, as you can see, R is equals to V over I. So R is equals to V over I, and the resistance is in ohms. We call this ohms. We call this amps or amperes. We call this volts or voltage. So that's formula number 1. Formula number 2, if they want you to calculate R total is a total resistance in the circuit. We say R total is equal to R1 plus R2 plus R3, depending how many resistors. If there are 4 resistors, R total is equal to R1 plus R2 plus R3 plus R4. Then formula number 3, if you are calculating the resistance of the parallel resistors, we're gonna say 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3 if there are 3 resistors. Then the fourth formula is for current. I is equal to Q over delta T. Q stands for the charge. The charge is in coulombs. C, that C stands for coulombs. We will explain this one when we get to the question where you are required to calculate current and you are given the amount of charge and the time. The time must always be in seconds. That time must be in seconds, not minutes. And then the last formula is V, potential difference is equals to W over Q. That W is called the energy, and the energy is in joules. We will talk about this later on. Then Q is the charge in coulombs. So we will go through this step by step, and then we'll see which formula we're going to use for which question. So let's go to question number 1. Let's look now at the questions. I'm going to use the same circuit now for these 6 questions. So question number 1 says, calculate the resistance or the effective resistance